Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous videos, I was actually explaining the 9th chapter of 9th standard science subject that was on gravitation. So I have covered most of the topics which were there in this particular gravitation chapter. So in this particular video, the remaining topics which were there, which were left out in this particular chapter, I will be covering. So now we will try to understand what do you mean by buoyancy. We have learned that when surface area reduces, the pressure increases because surface area and pressure are inversely proportional. Now, if a particular liquid or a gas is contained in a particular container, do they also exert pressure on the walls? Yes, of course they do, because this liquid or gas, or I'll just take liquid as example, this particular liquid also has mass. Whenever mass comes into picture, then acceleration due to gravity will also be there because gravitational force is acting on that massed object. So that means here liquid will also have certain amount of weight. So when mass is multiplied with this acceleration due to gravity, you will get weight of this particular liquid. Because this liquid has weight, that means weight is nothing but force. Whenever force is there and whenever there is area, then force by area will be pressure. So that means here the walls of this particular container, this is the wall of the container, and this can also be considered as the bottom surface of the container. So that means wall and the bottom part of this particular container has surface. Throughout that surface, water has got distributed. So that means here water is also constantly applying certain amount of pressure on the walls of the container. So that's why whenever in a container which contains some liquid, let's say water is there in a container, then here if small hole is there in this container, because of that pressure which is exerted by liquid constantly on the wall, that particular place has no boundary at all. It is just open. It is just some small hole is there in that particular container. So liquid will start pouring out like this through this particular hole. So this shows that even liquids are exerting pressure on the walls of container. This I have explained in 8th standard science subject. So there you can refer my previous videos for more explanation. So now we want to talk about buoyancy. So what do you mean by buoyancy? So now if you have some water in a container, so let us take a container, and if this container is completely filled with water, and if you have an empty bottle like this, so let's say there is an empty bottle and this particular empty bottle is closed with this particular cap. So now if you put this empty bottle onto this water, then this particular bottle will just float on the surface of this water. But now if you apply force on that bottle perpendicularly like this, so if you apply force on this bottle like this, and if you try to immerse that bottle inside water, then there will be resistance by water onto that bottle. So for example, now you have water inside a container and you are trying to push a bottle into this particular water. So when you are trying to push that empty bottle inside water, it will become difficult for you to put that bottle deep inside that water. Because when you are putting that bottle inside the water, so that particular water will apply certain amount of force onto that bottle. So that force is known as upthrust. So here water also applies certain amount of force onto the bottle. So that force is known as upthrust. So upthrust is force applied by water in upward direction against gravitational force. So force applied by water in upward direction. So force applied by water in upward direction can be known as upthrust given by this particular water, because this applied force, this water which applies force on this bottle is in perpendicular direction like this. So that's why this force can also be known as thrust, and it is in the opposite, it is in the upward direction, so that's why it is known as upthrust, or this upthrust is known as buoyant force. So this particular upthrust is known as buoyant force. So how much ever upthrust this particular water gives on that bottle depends on the density of that particular water. Different liquids has different buoyant force based on the densities of those particular liquids. Let us take one more example. So in two containers, if you take same amount of water, so let us take two containers, and if you take same amount of water in both the containers, and in one container which contains same amount of water, if you are putting rubber cork into this water containing container, and if you put an iron nail in the other container, then you can see that this particular rubber cork will start floating on this water, and this particular iron nail will be drowned inside the water and it will stay at the bottom like this. So here nail has overcome the upthrust and it has went and settled down in the bottom surface of the container. But here rubber cork was unable to overcome the upthrust of water and it remained on the surface of the water itself. So this is because density of this particular rubber cork, so density of rubber cork, so density of the rubber cork is less compared to density of water. So density of rubber cork is less than the density of water. So because density of rubber cork is less than the density of water, this rubber cork cannot be drowned inside the water. It cannot overcome the upthrust of water in order to settle down at the bottom surface of the container. So that's why it doesn't go and settle down to the bottom surface of container. It stays on the surface of water because water has more density. It is giving enough amount of upthrust for that cork so that cork doesn't drown inside the water. So here also this particular nail which is made of iron has more density. So in second case iron nail has more density. So iron nail has more density than the density of water. So here iron nail has more density than the density of water. Hence iron nail can easily overcome the upthrust of water and it can go and settle in the bottom surface of the container. Even iron nail experiences upthrust and rubber cork also experiences upthrust of water, but iron has more density, hence it goes and settles down in the container, but rubber cork has less density compared to the density of water, hence rubber cork remains on the surface of that particular water. Based on this particular principle, all the ship designing can be done. So now we will take one more example. So let us take water in a particular container and we will take one stone like this. So for this stone, if you tie a thread and if this particular thread is tied to a weighing balance like this, so let us say there is a weighing balance which is hung over this and this particular weighing balance is holding this thread. So now it will be showing certain amount of weight measurement on this particular weighing balance. So now when this stone is slowly immersed in this particular container of water, here the weight which is displayed on this weighing balance will go on reducing, and when this particular stone is completely immersed, the weight will become stagnant. That means initially the weight of this particular stone, let's say it has 100 Newton weight. I'm not talking about mass, I'm talking about weight. So if this particular stone has 100 Newton weight and this particular 100 Newton weight will be reduced to a certain extent. Just for example, I'll consider that will be reduced to 80 Newton, and when this stone is completely immersed, then this 80 Newton will be constant. So whenever this stone is put inside water, this 80 Newton will be constantly showing in this weighing balance. But the moment when you take this stone outside, again 100 Newton will be showed. When you half dip that particular stone inside the water, then it will show somewhere around 90 Newton. When that stone is fully dipped inside water, then it will show 80 Newton. Even further, after dipping fully that particular stone, even if you take that stone deeper and deeper, still the value will be 80 Newton only. So for example, if this stone is completely dipped like this, at that time weight was 80 Newton. Even this stone is brought till this particular extent, that is till the bottom of the surface of this container, till the bottom surface of this container, still it will be showing 80 Newton. The moment when you take this particular stone outside, so remember this stone should be tied to this thread and this thread should be tied to this weighing balance so that we can measure the weight of this stone. Now we can try to understand what do you mean by Archimedes principle. So to understand Archimedes principle, first we will look into the definition of Archimedes principle. So definition goes like this: when a body is immersed fully or partially in a fluid, it experiences an upward force. So when a body is immersed fully or partially in a fluid, it experiences an upward force. Always remember, it experiences an upward force from the liquid, and that particular upward force is equal to the weight of fluid which is displaced by it. So that means you can take a container which is completely filled with water. So this container should have no space at all. It should be completely filled with water, and inside this if you are putting an object, then now inside this particular container if you put object, still the water will be full in this container and some amount of water will be spilled out. So some water will be spilled out. So some amount of water will be spilled out of this container. The amount of water which is spilled out, so that amount of water spilled out, the weight of that water is equal to the upthrust of that particular water. So whichever liquid you are taking, in that liquid, how much amount of liquid is displaced by that object gives you the upthrust given by that particular liquid. So upthrust is also force and weight is also force. So how much liquid is displaced from the container when an object is immersed in that particular liquid, so that much amount of liquid's weight is equal to the upthrust of that particular liquid. So always remember, whenever a body is immersed fully or partially in a fluid, so how much ever liquid is displaced by that object, the weight of that displaced liquid is equal to the upthrust of that particular liquid. So after understanding about thrust and pressure, you have one example in this particular chapter, that is example 9.6. So in example 9.6, there is a wooden block which is kept like this. So this wooden block has height equal to 40 centimeter and length is actually equal to 20 centimeter and breadth is actually equal to 10 centimeters. So this is a wooden block which is kept like this. So here breadth is equal to 10 centimeters. Now if the same wooden block is kept in this way, so if this 40 centimeter surface is made to come to the bottom, then it looks something like this. So now the same object looks something like this. So now this length becomes 40 centimeter, breadth becomes 20 centimeter and height becomes 10 centimeters. So the same object is kept in this manner. So now you have to calculate pressure in this first case and also you should calculate pressure in this second case, because this particular wooden block has certain mass. So because this wooden block has certain mass, when it is multiplied with acceleration due to gravity, it gives the weight of this particular wooden block. In this case also, the same wooden block is kept in other fashion. So that means here also weight will be same, that is W. So in both the cases weight is same, but pressure will be different. You should calculate that particular pressure. First you should calculate what is the weight of this particular wooden box. So in both the cases, this particular wooden block is perpendicularly applying weight on the surface. So because this particular wooden block is perpendicularly applying weight on this particular surface, this can be known as thrust applied by this particular box onto the surface. So thrust is nothing but force which can be calculated as mass times acceleration due to gravity. So now what is the mass of this particular wooden box? Here mass is given as 5 kg. So 5 kg into 9.8 meter per second square is there. So here thrust is equal to 49.0 Newton. Now you have to calculate pressure in first case. So now we are calculating pressure P1 in first case. So in pressure P1 you have to consider area A1. So here thrust is same. So thrust will be same divided by area A1. So what is area A1? In the first case area is this particular 20 centimeter into 10 centimeter. So that area of contact you have to consider. So 20 centimeter into 10 centimeter. So 20 centimeter into 10 centimeter, if you convert this into SI unit, then it will be 0.2 meter into 0.1 meter. So now area 1 will be equal to 0.02. 0.2 into 0.1 is 0.02 meter square. Meter into meter is there, so meter square. So now pressure 1 you can calculate, that is in the first case. So this is a question. So pressure 1 is 49 Newton divided by 0.02 meter square. So area is 0.02 meter square. So 49 divided by 0.02 will give you 2450, that is 2450 Newton per meter square. So pressure is always measured in SI unit, Newton per meter square. Or so there was a scientist named Blaise Pascal. So in order to honor this particular scientist, whatever the second name this particular scientist had, that is Pascal, the same SI unit is used for pressure. So Newton per meter square is also the SI unit of this particular pressure, or you can put Pascal. So small p you should write, and you should write the full Pascal like this. So either Pascal or Newton per meter square you can put as the SI unit for pressure. So now coming to the B question, here the case is different. The same wooden block is kept in this way, where its length and breadth is equal to 40 centimeter into 20 centimeter. So while calculating pressure P2, you have to take area 2. So the same thrust will be there because weight of the object is same, but the area is different. So area 2 will be there. So area 2 is equal to 20 centimeter into 40 centimeter. So now you have to do 20 centimeter into 40 centimeter, that is almost equal to 0.2 into 0.4 meter into meter. So 0.2 into 0.4 is 4 2s are 8, so 0.08 meter square. So now pressure 2 will be equal to, in the next page I can write this. So now pressure P2 is equal to thrust by area. Thrust is 49 Newton divided by area we have calculated as 0.08 meter square. So when you do 49 divided by 0.08, you will get 612.5 Newton per meter square. So now when this wooden block was kept in this fashion, the pressure was equal to 2450 Newton per meter square, that is 2450 Newton per meter square. The same wooden block which has same weight, when it is kept in this manner, the pressure was equal to 612.5 Newton per meter square. So the answer for B question is 612.5 Newton per meter square, and answer for A question is 2450 Newton per meter square. Because here surface area, the covered surface area is less, pressure is more. Because here covered surface area is more, pressure is less. That's it. Whenever surface area increases, pressure reduces. Whenever surface area is reduced, then pressure will be increased. So pressure and surface area has inverse proportionality relation. So this is all there in this particular video. Like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.